Welcome back. In this video, we're going to continue with section 4.4 on solving linear systems of linear equations in three variables. So we've gone through kind of the instruction part of this section. What's left to do more or less is the examples. So let's get started with this one. For this one, what's different is that each equation has only two out of the three variables in it. So here we have 3x minus 4z is -1. That one's missing a y term. And then 2y plus 3z is 2. That one is missing an x term. And 2x plus 3y is 6. That one, of course, missing the z term. Students frequently find these kinds of problems more difficult just because they don't seem to fit the pattern that they wish to follow. So for here, you get to make a choice. Because each of the equations is already only in two variables, step one is kind of already done for you. So we get to decide at this point which variable we'd like to eliminate. We could use the first and second and eliminate z. We could use the second and third and eliminate y, or we could use the first and third and eliminate x's. So I don't, there's none of those dramatically easier than the other. Actually, let me take the first two and eliminate z's, just so that we will have chosen. Okay, so I'm going to number the equations as before so that we can refer to them. So I can see that the coefficients of z are already opposites of one another. So I'm going to scale them to be 12z and -12z so that the z terms will go away. So the first one, I'm going to multiply by 3. So let's multiply by 3. And this will give us 9x minus 12z. That's equal to -3. The second one, we're going to multiply by 4. That will give us 8y plus 12z, and then that's equal to 8. And then the last equation, nothing is happening. So here, when we add together these two equations, we'll have 9x plus 8y. The z's are gone, which was the whole point. And then 8 plus -3 gives 5. So now that we've finished this, we have another equation with x and y in it. Our equation 3 had x and y in it. So between the two, this gives us a system of equations just in x and y. And we should be able to solve that. So let's give that a try. Let me write the two equations next to each other so that we can decide what to do. Okay, so for this one, we'll go ahead and use elimination again because the coefficients of all the variables are not 1. So here we could choose to either eliminate x's or y's. I think we'll eliminate x's. So if we're going to eliminate x's, I'm going to multiply the first equation by -9. And then the second equation by 2. So this will give us -18x, -27y. That's equal to -54. Sorry, 63. 54, I was right the first time. Okay, and then for the second one, we're multiplying by 2. That'll give us 18x and 16y, and then 10. Okay, now we're going to add these two together. We'll see that the x terms are gone. So we have 27 minus 16. That will give us -11y, and then -44. That makes it so that y is 4. Okay, now we need to start working our way back to the other variables. We have a value for y. We can use any of the xy equations to get our value for x. So let's use the 2x plus 3y equals 6 one. 2x plus 3y equals 6. Here, if y is 4, 3y would be 12. So then 2x is -6 and x is -3. Okay, now we have x and y. Let's go ahead and get z. Here's one we can use. 3x minus 4z is -1. Okay, and we had x, which was -3. So 3 times -3 is -9. And then minus 4z is -1. Okay, let's subtract the 9 from both sides, that is add 9 to both sides. And so this will give us 8 on the right side. So that makes z be -2. All right, putting together the pieces, our x was -3, our y was 4, and our z is -2. Okay, so once again, there's a lot of choice in working with these. For this one, I began by eliminating z's. You could have eliminated any variable in that first step if you had wanted. Okay. All right, so here's one to try. Let's take a look at this one. For this one, why don't you give this one a try yourself? Pause the video and try this one, and then restart the video and see how you did. Okay, I'm going to start by numbering the equations. For this, again, depending on which choice you make, your work is going to look different than mine, and that's okay. Probably most people will pick to eliminate x's here because the coefficients are just ones and negative ones. But if you wanted to, you could eliminate any of the variables. So the second equation has a -1 for a coefficient of x. So we'll use equation 2, and then let's take 1. Okay. So we'll get our equation 4. We'll get that by adding together equations 1 and 2. Okay, so let's add together equations 1 and 2. So x plus minus x is no x's. 2y plus y is 3y's. 6z plus -2z is plus 4z. And then 5 plus 3 is 8. All right, so this gives us an equation that doesn't have any x's in it. So now we need another equation that doesn't have x's in it. This will be equation 5. We'll get that by adding together equations 2 and 3. So adding together equations 2 and 3, we have minus x plus x is no x's. Y plus -4y is -3y. And then z's, -2z plus -2z is -4z. And then 3 plus 1 is 4. All right, so now we're ready to solve the system of equations given by equations 4 and 5. And you'll notice that the left sides are opposites of each other. So when we add them together, 3y plus -3y is 0, 4z plus -4z is 0, and the right side is going to be 12. So we get 0 equals 12, which is, of course, false, right? So what that means, as it did in the two equations and two unknowns case, is that there's no solution. When you get an absurd statement like this, one that's false, and there's no variables in it, that means that there's no solution, right? No solution. You could write a big fat 0 with a line through it, meaning the empty set. If you like, you could write curly braces with nothing inside. Okay. In general, when you get a false statement, something that's always false, one of two things has happened. Either you made a mistake someplace, or there's no solution. In all likelihood, there was just no solution. Okay. That's kind of unsatisfying when that happens, but that's the way it goes. Okay, so let's try the next one next. All right, so again, I've numbered the equations. We're going to decide on a variable to eliminate. I think we'll go with z's. Okay. Yeah, let's go with z's. So I'm going to use equations 1 and 2 first to eliminate z. So this will give us an equation 4. We're going to get this 4 by multiplying equation 1 by -2, because I need to turn this minus. All right, sorry about that. Zoom crashed again. Right, as I was saying, we want the coefficients of z to be opposite. So in the upper equation, that minus z, we're going to multiply by -2 so that we have positive 2z. And then we're going to add to it just equation 2. Okay, so there's our directions. All right. So we're going to take -2 times equation 1 and add it to equation 2. So -2 times x is negative 2x. Negative 2x plus 2x is no x's. That's pretty great. And then now for y's, negative 2 times y is negative 2y. Negative 2y plus 4y is 2y's. Then negative 2 times minus 1z will be plus 2z. Plus 2z minus 2z is going to be plus 0z's. And then we'll have negative 2 times 0 is 0, plus 6 is 6. Okay, so now this will give us that 2y is 6, and so that y is 3. So this time we got lucky. We were able to eliminate two variables using just one step, so that's pretty nice. So now we're going to start simplifying this further by replacing y with its value, which was 3. So far we've used equations 1 and 2, and so let's involve equation 3 now. And so let me recopy equation 1, replacing the y by 3. And then we'll also take equation 3, replacing y by 3. Okay. All right, so we've taken equation 1. We replaced the y with 3 because we found out that y is 3. We took equation 3 and also replaced y by 3. And so now this gives us two equations in x and z that we'll be able to solve. So I'm going to push the constants all to the other side. So we'll have x minus z is negative 3. And then 3x minus 3z is negative 9. All right, so now you may notice that the second equation is 3 times the first equation. If you don't notice that, then we would continue solving this. We could multiply the first equation by negative 3 and add it to the second equation. This will give us 0 equals 0. When this happens, or you get some other statement that's always true, then this gives us the other case where there are infinitely many solutions. In general, when you're doing this process, you're going to get 3 numbers, an x, and y, and a z. If you don't, you may get something that's always false, in which case there's no solution, or you may get something that's always true, in which case there are infinitely many solutions. Okay. All right, so we're going to finish with a little story problem. So this is kind of long, but it'll be all right. Here it says, a soccer team sold 3 kinds of tickets to its latest game. The adult tickets sold for $10, student tickets sold for $8, child tickets sold for $5. The number of adult tickets sold was twice the number of child tickets. They sold a total of 600 tickets and made $4,900. Based on this, we want to find out how many of each type of ticket were sold. So what I would do is start by picking out variables. We're going to let X be the number of adult tickets. Y will be the number of student tickets. And then Z will be the child tickets. Normally, I like to use variables that kind of match what we're talking about, but we're so used to using X's and Y's and Z's in this context, I think it'll be simpler than if we start using A's, S's, and C's, which would be kind of unpleasant. All right, so X is adults, Y students, C and Z's child. Okay, so then the first sentence is just giving us background information. There's 3 kinds of tickets. The second sentence is telling us the prices for each type of ticket. Adults are $10, students are $8, and then child are $5. So now we start getting into where we can write the equations down. The number of adult tickets sold, that's X, was, that's just past tense of is, so equals, twice the number of child tickets. So X is going to be 2 times Z. That's our first equation. They sold a total of 600 tickets. So that means that X plus Y plus Z is going to be 600. That's the equation about the number of tickets. The last equation has to be about the amount of money that was made. So it's $10 for each adult ticket, and then $8 for each student ticket, and then it's $5 for each child ticket. And that gave $4,900. Okay, that's going to be our system of equations representing this ticket problem. Make sure that you understand where we got that from the wording before we go into solving it. Okay, so now let's forget the story and just solve the problem at this point. Here we're told what X is in terms of Z, so it probably would be a nice idea to go ahead and replace X by 2Z in the second two equations. That'll get us down to a system with just Y's and Z's. So let's do that. So X will be replaced by 2Z. So we'll have 2Z plus Y plus another Z. That's 600. Let me clean that up a little bit. That'll be Y plus 3Z. Keep it in alphabetical order. Y plus 3Z is 600. For the next one, X is 2Z. So we'll have 10 times 2Z, that's 20Z, plus 8Y plus 5Z is 4,900. Again, cleaning things up a little bit, we'll have 8Y plus 25Z is 4,900. Okay, so then we're going to work with the two highlighted equations involving Y and Z in order to get this done. Most of the time we use elimination, I think this time, because it just looks good. I want to use substitution for this. We'll let Y be negative 3Z plus 600, and we'll substitute that into the second equation. So we'll have 8 times negative 3Z plus 600. Okay, that was our Y, plus the 25Z, and that's 4,900. So finally, this gets us to where we have just Z's. So negative 24Z plus 4,800 plus 25Z is 4,900. Okay, let's subtract 4,800 from both sides and combine the Z's. You should end up with 25Z minus 24Z is a single Z, and then just 100 on the right. Okay, so that pretty quickly gives us a 100 for Z, and then we can start working our way back to get the values for the other variables. Okay, here we're told the value of Y is negative 3Z plus 600. That will give us 300. So Y is 300. And then we're told originally that X is 2Z. So that will be 200. So the numbers here are nice and clean, actually kind of surprising. So here the number of adult tickets was 200. And the number of student tickets was 300. And then the child then was 100. All right, that takes us to the end of our work with systems of 3 equations and 3 unknowns. For this, a lot of times it's easy to make one little mistake and then the whole thing is wrong. So make sure that you're really careful. Go step by step and really make sure that you understand the reasoning for the steps you've taken. Anyhow, that's the end of this section. Let me know if you have any questions and have a great day.